In this video, we are going to discuss about the entropy. We have already discussed about the information uncertainty and few examples about the information in our last session. In this session, we will define the entropy and we'll try to discuss information rate and try to do some few example about the entropy for better understanding. Let's start from the definition of the entropy. Entropy, it is defined as the average information per symbol. For example, suppose we have m messages as m is equals to m1, m2 up to mn, and the probability of each message is p1, p2 up to pn. We know that the information of each message is equals to I is equals to log to the base 2 of 1 p by p1 and I2 log base 2 of 1 by p2, and the information of n message in is equals to log 2 of 1 by pn. So this definition we have already covered in our last session. For better understanding about the information, you can go through our last session. According to the definition of the entropy, we can write the entropy as a ratio of the total number of total information divided by the number of messages. Total information is the information by each message. So I1 plus I2 plus dash dash up plus IN divided by n number of messages. So that is why we are dividing with n, or we can write the same formula in term of summation. So if we are talking about the discrete symbols, so if we are talking about the discrete symbols, then we can write this entropy in term of summation. I is equals to 1 to n, the probability I multiplied by log 2 1 by pi. So like if you are multiplying the probability of a symbol with its information, then it will give you the entropy of that symbol. Secondly, we will try to do some properties about the entropy. Entropy is zero if no uncertainty. For example, we have already know that if no uncertainty means that we are 100% confidence, we have the 100% knowledge what's going on. So if we have 100% knowledge, so it means that either it is zero, the probability is zero, or the probability is one. Because if the probability is zero, so it means that something is not happening. But if the probability is 1, then we know that something is happening. So if you insert this probability either 0 or 1 in this formula, so if the probability is 0, so 0 multiplied by anything, the answer will be 0. So if you insert probability 1, then we know that log 2 of base 1 will also be equals to 0. So 0 multiplied by 1, the answer is 0. So hence entropy is 0 if no uncertainty, or if you are 100% confidence, then the entropy will be 0. Second property is that for pk is equals to 1 divided by m for all m symbols, then the symbols are equiprobable. So you can write the entropy will be equals to log 2 log 2 of m. So that is the simplification. Like if you know the probability of m symbol is equals to 1 by m and the symbols are equiprobable, then the entropy will be written like this, like h is equals to log 2 of m. For example, if we insert the probability pk is equals to 1 by m, so then the entropy H is equals to, using the formula Pk log 2 uh, log of base 2 of 1 divided by Pk. So we know the probability Pk is equals to 1 by m. So this is the summation from k is equals to 1 to m. So the summation of 1 by m will be equals to the adding m times 1 by m. The answer will be equal, because m, if you add all m and the total is m, so m by m the answer is 1. So that is why this term is equals to 1. And then 1 multiplied by log 2, 1 divided by 1 divided by m. So this is third denominator, it will become numerator. So that is why you can write 1 multiplied by log 2m, so that is equals to log 2m. Or you can say this is upper bound of entropy, and then you can assign it as H max. The other parameter is source efficiency. So the source efficiency is basically the ratio of the entropy divided by the upper bound of the entropy, or H max. And we already know H max is equals to log 2 of m, and H is the entropy. And the other parameter is the redundancy of the source, so which is equals to 1 minus efficiency of the source. So like these are the few parameters that you can calculate using these formulas, and they will help you in solving the few examples. The last parameter is the information rate. So information rate is equal to R multiplied by H, and it is in bit per second. So we know H is the entropy and R is the rate at which message are generated. So your information rate will be R multiplied by H. So this is the other parameter that you can calculate. So if we solve one example so that we can better understand how can we calculate the entropy. For example, you have four symbols, and each symbol has the probability, like x1 the probability is 0.5, and the x2 symbol the probability is 0.25, x3 symbol the probability of x3, and x4 is equals to 0.12, and you are asked to calculate the entropy. We know the formula of the entropy is equals to the summation from I is equals to 1 to m pi log to 1 by pi. So what is the probability of first message? So because we have four symbols, so I will start from 1 and up to 4, and so here we can write the answer like the total information, because log 2 1 over pi, basically this is the information. You can donate it as information, and then you can calculate the information using this formula. So this is the information of first message, log 2 1 by zero point 0.5 plus log 2 1 by 0.25 plus log 2 1 by zero point 0.5 plus log 2 1 by zero point 0.5. Or you can multiply this two term by 2, and then write log 2 1 by 0.125. So the information of that is 1, information of this is 2, information of this is 3, information of that is also 3, and you have 9 bit. And no, you know the entropy is basically if you multiply the probability with the information and sum them up for all the four symbol, then you will end up with the entropy. So the probability of first message is zero point 0.5 multiplied by information. The second is second message information is I2. The probability is 0.25. In third and fourth, the probability 0.125, and the information is 33. So if you multiply them, then the answer will be zero point 0.5. Its answer will be zero point 0.5, and then its answer is 0.35. Its answer is 0.35. So the total entropy will be equals to 1.75 bit per second. That's all. I hope that you understand this session very well. But if you still have any question, you can write the question in the comment box, and we will try to give the answers. So thank you for watching the video.